So did he talk about that in class?
Mm-hmm.
Okay.
And the treatment for cochlear or for sensory neural is cochlear implants.
Okay.
We didn't talk about that at all, so maybe tomorrow we will.
I don't know.
Okay, when we're talking about balance, we're also talking ears, right?
Mm-hmm.
Remember this stereocilia? We're going to be talking about that in just a second.
How do you spell stereocilia?
Stereo, like what you listen to?
Like a stereo? Okay.
Yeah, and then C-I-L-I-A. Okay, so you have two types. Two types of things that help you with balance. You have static, and you have dynamic. They function similarly. Here we have stereocilia. And there's this gel that sits on top of it. And this is in the vestibules. What are your two vestibules?
The utricle.
Right, sacral and utricle. And there's this gel type of stuff that sits on here. They call it gelatinous mass. And inside of this gelatinous mass, there's certain particles. I'm not sure what they're made out of, but they call them otoliths.
This is for static, right?
Yep.
And dynamics, this semicircular.
Yep.
Okay, so that squiggly is the vestibules, and then the little squiggly is the gelatinous mass.
Wait, what?
I think he's drawing that right
The,
there.
the big squiggle right there.
Where's the big squiggle? Oh, these are stereocilia.
Oh, okay.
Sorry, I'll
So
label
you
it.
have the stereocilia, and then you have the jello pan going over the top of the hairs, filled with
Okay.
rocks.
Jello on the rocks.
Yeah.
Sweet.
Okay, so this is going to detect head position and acceleration and deceleration. I never spelled deceleration. Who spells this word? I don't know if this is spelled right, guys.
I know.
Forgive me. I know not what I do. Is that deceleration? I feel like it's totally wrong. But that's what we're being able to distinguish with the structure of the ear. So as we move our head, this gelatinous mass kind of moves, and these otoliths will like sink down, and it'll touch the stereocilia and help us know, okay, we're falling down this way. Our head's just tilted. The earth is still down here. Gravity's still pulling us this way. And so gravity just kind of pulls on it, and we can kind of feel where it's getting pulled in our ears. And that will send action potential back to our brain and kind of help us figure out where we're at in space.
This is happening in the utricle and the saccule?
Yes.
Okay.
Where are those at?
Right there. Where that is. It's like underneath the semicircular ampullae.
I was thinking they were. So it's in the canal? Or no?
Underneath them.
Okay.
They're like, I think I remember there were two like almost like domes underneath the canals.
Correct me if I'm wrong. It's the vestibular nerve that, right? Vestibular nerve that
Vestibulocochlear.
takes it back to the brain.
Mm-hmm.
Vestibulocochlear. Where is that?
There's two nerves, they combine and make the vestibulocochlear.
Okay.
So your cochlear nerve runs from your ear for sound. This runs from your ear for balance. They combine and make your vestibulocochlear. Right?
Gotcha.
Kind of weird how it works. You have any questions? No? Yeah. Ready for dynamic?
Mm-hmm.
Okay, so this is taking place in your semicircular canals. Inside your semicircular canals, you have something called the cupula. And the cupula starts from right here. It's kind of like the base, and it's just tall enough to kind of barely touch the other side. and there's liquid in here. This helps detect head movement. So when you go to a roller coaster park, well, okay, let's take a step back. Do we understand inertia? Car kind of accelerates, and it slams on its brake, and your body still wants to keep moving. It's a similar thing here. Your head might get rotated this way as you're falling down or something, but the liquid in there still kind of wants to stay where it's at. So it's going to kind of push back this way as it's turning down. And it's going to push the cupula just a little bit. As it pushes, and you can feel your cupula kind of being stimulated by that touching sensation right there, you can detect head motion. So when we go to the roller coaster park, you're like, man, that roller coaster was sweet. My cupula was so stimulated. Your friend's like, yeah, man. It's like, it's crazy how much you'll pay to stimulate your cupula, right? Next time you guys go to Six Flags, that's what you're gonna be saying.
Probably
Watch.
not.
You'll be thinking it though.
Yeah.
You're not gonna say it.
You won't verbalize
But
it.
I don't think it.
You're like, oh, my cupula.
I'm gonna say it.
Biggest nerd there.
My parents will make me walk home.
They're like, oh, I don't know that girl.
Back to me.
This is not our daughter.
Any questions with this?
Can you just explain what happens with inertia one more time?
Yeah, so with inertia, let's say like you're in a car that has a lot of torque, so it can accelerate really quickly. The rule with inertia is like when things are in motion, they want to stay in motion. When they're not, you don't really want to be. So like your body's not really in motion, but when the car takes off, your body kind of tries to stay where it's at. So you kind of get pulled back. And then after a while, you kind of adjust. And then you slam on the brakes, and your body wants to keep going, but you can't. So that's inertia. Does that make sense?
Well, yeah, but what happens?
So with this, the bones are moving, right, with your skull, but the liquid's wanting to stay where it was. As a result, this gets pushed on.
And that's how the cupula detects where you're at. Where the
Yeah.
head movement.
And that's why you get motion sickness, right?
Yeah. that would
It's
be-
the liquid in your ear, the imbalance in
It's
it.
still moving or something?
Yeah.
So it makes you like,
So,
ugh.
that makes sense, at least.
Okay.
Makes sense? Cool? All right.
So it uses in the book like an example of a dancer doing a cartwheel, or a front cartwheel. I don't know.
See that front handspring?
Sure. And would we have to know like on the exam, like which canal is being stimulated at which point, or?
I don't think so.
Okay.
I mean, just gotta know how they're applied, I guess. I mean, you're gonna use them both to some extent, right?
So
You can't have a different head position unless your head moves.
if I'm going forward, the fluid's like staying there and it like kind of bounces on the bottom of the cupula.
Yeah.
Okay.
Yeah, I mean, you have 3 different semicircular canals, and so anyway, it's gonna cause it to shift a little bit. Cool.